Hi guys, this is a Headfirst MTL with MIDi. It's a 100 watt build. It's been built for a guy over in Perth, and I've spent the week just kind of testing and tuning this thing in. So how is it different than a standard MTL? Well, with the Headfirst builds, it's built using custom PCB that I've designed. You can use these PCBs to build your own. Many have. PCB is used at the heart of this thing. It has a global master. Okay, so each channel, you've got the rhythm channel and the lead channel, both have independent volume controls. You have a global master on the front. This amp has been fitted with my MIDi board, so for MIDi switching. So I want to use this video to demonstrate how you can use MIDi switching to integrate into one of your amps, particularly an amp like this that has basically 4 modes, right? So you've got a rhythm channel with no boost, a rhythm channel with boost, a lead channel, and a lead channel with boost. So there's 4 modes. Now, you can control this with a conventional foot switch, of course, but with MIDi, you've got the ability to define these settings, have them recalled using program change messages or control change messages for that matter. Because we've got digital technology in here controlling the switching, I've actually got soft button switches on here. So you can control the channels just with these soft buttons on the front of the panel here. I'm switching between obviously lead and rhythm channels there and bringing the respective boosts in and out. I've got the head connected to my Axe effects down here in the rack, from a MIDi out of the Axe into the MIDi in on the Headfirst here. I've got 4 scenes set up. They are scenes 5, 6, 7 and 8 on this preset. And you can see from the signal chain, my guitar comes here on the input. I've got nothing running in front of the amp. I'm going out of the Axe into the front of the amp here. Okay. From the back of the amp, it's into a reactive load. The reactive load is giving me a line out, which is coming back in to this input here. Okay, and this out here, out 3 and 4, is a stereo external loop, which I'm running a PCM 80, a Lexicon PCM 80 in here. So all of the pan delays that you're hearing in this clip are coming from the PCM 80. You can see there's nothing set up in the Axe in terms of time-based effects. And then from the output of the Axe, we're going into my Apollo Twin and into Logic. Okay, and the other thing that I've got in my preset here is the MIDi block. Okay, so the Axe Effects MIDi block, it's scene dependent. So with my, as I said, I've got 4 scenes set up from 5 to 8. If I click through the scenes, you'll see 5, 6, 7, and 8. My amp's changing. Right, that's MIDi switching happening there. So scene 5 is rhythm channel with no boost. Scene 6 is rhythm channel with boost. 7 is lead, and 8 is lead channel with boost. I can obviously, if you know the Axe effects, you can control it from the front panel here too. So if I just scroll through these, you can see the switching is instantaneous, right? Very, very fast. And so you can hook this up. So if you've got a kind of MIDi based rig, right, with your, you might have some like an Eventide H9 or some of the Strymon based effects or whatever, any kind of MIDi based setup in your rig, use the MIDi board, get your amp switching at the same time. Let's go through some core tones. Okay, so the rhythm channel on this MTL, let's start there. I've actually tweaked this. It's not a stock MTL rhythm channel. I find the rhythm channel in the MTL a bit underwhelming, to be honest, so this is kind of tweaked a bit to get a little bit more grind out of it, I guess, so we can get some, let's call it kind of AC/DC style rhythm sounds out of it. Without the boost, it's still quite clean, but there's a bit of grind there. let's move it to rhythm with boost. Oh, wrong way. This way. Rhythm with boost. This is C number 6 on the axe, and I flicked across to program number 2, right? So I've got my 4 presets on here, a MIDI program 1, 2, 3, 4. Stored in the chip. When you power off the amp, those settings remain stored on the MIDI chip, right? So they can be recalled. Anyway, rhythm channel with boost. Yeah, that rhythm channel with the tweaks, I can dig it, right? So let's move to lead. On the lead channel, we have the saturation pot, right? This is basically controlling the gain of a gain stage that's kind of in the middle of the preamp. The difference between, in the Wizards, the MTL and the MC2 is this extra gain stage, right? So you can think of the saturation control as an extra gain, adjustable gain, and it's really controlling the gain that's coming from, as I said, that extra gain stage. So here we are at midday. You've heard the tone. Let's wind it back. Bring it up. This one. You get a lot of gain here. Gain channel also has this shift switch here. This is controlling the value of the slope resistor in the tone stack. I'll flick it back and forward. You'll hear the difference, right? It's quite a dramatic difference in the setup of the EQ in the amp. So you can kind of flick it to the setting you like, and then dial in the EQ from there. One way or the other, you'll hear it. So here we are. This is the kind of the brighter setting. let's move over to the lead channel with boost, as if anyone needs more gain than that, but hey, it's available. Right, so let's move to scene number 8, and here we have it. Right, so lead channel, you can see the saturations at midday. I've got the gain about 6, which is kind of for me the sweet spot. You can crank the gain more than that, but it gets a bit too compressed, I find. You can certainly do it, but this is kind of saturation midday, gain at 6, and you can see I've got the channel volume up a reasonable way as well, which with the Global Master makes this possible. It's always worth noting that in these Wizard style amps similar to the Marshall Jubilee, these channel volumes aren't at the end of the preamp. There's another gain stage that follows these volumes. So if you run these channel volumes very low, you're not going to be driving that last gain stage, and you're kind of missing out, I guess, on that extra bit of push. So I find the Global Master's really good addition to these, because you can kind of crank these channel volumes as if you had the amp really cooking, and still end up with something that's from a volume perspective at least you can control. It's a 100W MTL with MIDi. It's going to Michael over in Perth. Brand new amp for him. Mike, mate, I hope you love this amp. I've spent the week with it, fine-tuning it. I really want to keep it, but we'll ship it, mate. Hope you enjoy. Cheers. Okay guys, so this is the 100W MTL that I've just featured in this clip. Now, the thing that I wanted to point out on the bench here is really about how to install the MIDi control. So on the MTL, what I've got is 3 functions that are relay controlled, right? So you've got your channel. So this relay here is principally switching between the lead channel and the relay. It flicks this relay over here as well, so they're kind of together on the same switch, if you like. And then each of these 2 relays here is controlling the boost for the rhythm channel and the lead channel. So on the board, you've got an R2, an R3, and an R4 pad. And these are the pads that activate the relay coil by grounding. Right, so you've got to ground the pad here, respectively, just chassis ground, and it will activate the coil and then therefore activate the switch on the relay and change the circuit as necessary. Now, this board has been done with 12-volt relays, right? So this is a 7812 voltage regulator here, giving me a 12-volt DC line. We're using this DC line for these 12-volt relays. Also, 12 volts is a good option if you've got a power transformer that can serve that up, because we're doing DC heaters on these first 3 preamp tubes. And you can see on my chassis here, this is drilled for 6 12AX7s. The MTL board uses 5, right? It doesn't use a tube loop. So we're using our head first solid state metro loop here on this one. And I've got the first 3 preamp tubes on DC heaters because you tend to pick up noise in the amp, first through the first few gain stages. The later gain stages, not so sensitive. So the phase inverter and this last gain stage here for the lead channel is wired as normal AC heaters. Okay, so moving to talk about MIDI, right? So if you were just doing normal switching for these relays, you would just have regular toggle switches like this one. Okay, this is actually the rhythm bright switch. This is the mid shift switch. These are normal switches. You can see I haven't wired them yet, but we'll do that. We'll do that next. Boost, channel, boost. These are the three functions here, right? Because I'm using MIDI, we want to use momentary switches, right? So you've got two options, really. You can use a switch like this, which is a regular toggle, but see that? It just clicks override. It's not latching, it's a momentary switch. Because the MIDI board, here it is here, ready to go in, right? These are the ins. Now I've got a separate video detailing kind of how this all works, right, what it's doing. So do check that out if you're interested in putting one of these into your build, or even into your existing amp that has relays on it. You need to toggle a momentary ground, right, on these inputs, and that in turn, the chip here will interpret that signal and it'll set a latching state via this NPN array chip here. And on the bottom of the board, these are the outputs here that will actually control the relays. So a pulse here will set these off or on. That's the way to think of it. And then obviously with MIDI, you can store those as presets, program change messages. Okay, so you've got to have one side of your momentary switches here grounded. We're using these push buttons. Right, these push button switches are pretty cool. You can use any kind of push button you want, really, but I've just kind of settled on these after trying a few different ones. I think they look pretty cool. And you just got a wire from each side of the switch here to the input functions here, and then in turn we'll wire from here out to the relay controls, which is R2, R3, R4, as I said, respectively. Let's do that next. The MIDI board needs a 5-volt DC supply, right? So these logic chips here, they all run on 5 volts. That's very common in electronics. Now, if your main board, if you've done 5-volt relays, right? So you weren't doing 12-volt DC heaters. Let's say you had a 7805 regulator here and you had 5-volt relays here, which I know many people do. I've got lots of builds that I've done with 5-volt relays because of what the power transformer had as an option. And if you're doing that, right, you can just run your 5-volt supply from the MIDI board straight off one of the VCC pads that I have on the board. So if you refer to the board layout PDF that I supply in the documentation folders, you'll find that around these relays I've got VCC pads, i.e. low voltage DC line that you can use to power the MIDI board. This is a 12-volt board though, okay? So what we're going to do is we're going to still tap off the 12-volt DC line and we'll run it to the MIDI board. The MIDI board's got its own voltage regulator. This is a 7805 regulator, right? So I'm going to use this to knock down the 12-volt DC supply to a nice steady 5-volt DC, which is able to be used by the chips on the board. Okay, so the MIDI board is now in, right? So I've got two standoffs, one here, drilled into the side of the chassis. Just a tip, I've mentioned this before, but always worth remembering, before you populate your board, here's an unpopulated MIDI board. If you receive one of these from me and you're going to mount it into a chassis that is not pre-drilled for it, use this as a template before you populate it with components, right? So, stick it on your chassis, obviously on the side from the outside, and just use maybe a texter and just mark where the hole positions are. Perfect template, right? Just a little tip there. If you populate it with components, it's going to be hard to do that. Not the end of the world, but do it. I recommend doing it before you put the components on. Now, A couple of things I need to tell you about with this MIDi board. Okay, so these three momentary switches here, these are soft button mini switches, right? This is the momentary ground, right? So you can see on one side of the switch is, at the bottom, I've got a bus wire which connects to the ground. And then I've got three wires here. You can see I've got green and white and orange wire. They are running to toggle. So I've got toggles and channels. The toggle 1, 2, 3 on the MIDi board here. The reason I'm using the toggles rather than the channel function is because with these push buttons, they're single state, right? All I can do is send a ground pulse. It's not like one of these switches here, which is momentary but bi-directional, left and right. If I was using one of these, then I'd probably use the channel function on the MIDi board. I'm not. I'm using toggles because the toggle is on, off, right? So on, off. It's enough to switch a 2-channel amp back and forth. I'm pressing to this because that's the relay that flicks the channel, right? So these three, 1, 2, 3, go to channel 1, 2, 3. And then at the bottom of the board are the outputs. Here we go. Here's our board. Hopefully that's coming through. So I've got 1, 2, 3 on the input toggles. And down here is where you connect your relays, right? So toggles, 1, 2, 3. You need to make sure that you match them up. So if this is 1, this is your lead boost function, which is this relay here. It's R3, right? So R3 needs to connect to toggle 1 on the output. This is toggle number 2, which is the channel back and forward. The channel is R4 on the MTL. So you need to connect toggle 2 output to R4. This is toggle number 3, which is the rhythm bright. You need to connect output number 3 to R2, which is the rhythm bright relay. Okay, one thing that I discovered, which is really important to know with this build, 12-volt relays, okay, and a 5-volt MIDi chip here. On the MIDi boards is an NPN array chip. I'll grab my unpopulated board here again. This is our 80 mega chip, which has got my firmware loaded on it. Right. This chip here is the optocoupler. So this basically allows the MIDi coming in here to be optically isolated and then transmitted to the chip. And this down here, this chip here is the NPN array, which is driving the relays. Okay, so this is the thing. This is the chip that's actually doing the business to drive the relay coils, you know, set them to ground and let them to activate and back and forward. Now, there is a small issue that you need to be aware of and work around when you're dealing with a 5-volt logic circuit and 12-volt relays. There is a problem that the NPN array, if the NPN array chip is operating at 5 volts, it won't drive the relays properly. It won't allow them to connect off and on or activate off and on. So I wired this in and I had it set at 5 volts and I had my 12-volt relays here, and when I tested it, I could activate the coil, all right, click it on, but I couldn't click it off. And I'm going to give credit here to my good mate and mentor, Don Kohinger from Southern Cross Audio, Melbourne Amp Company, who had already found this problem and had told me about it, and it just saved me God knows how many hours. you need to run the NPN relay, the NPN chip at the same voltage that your relays are at. All right, so I'll show a picture on the screen now. You can see the little workaround. What you need to do is the power that is providing, the power to this chip here is provided on this pin right at the end here, at the bottom. If you've got that pin connected into the board, it's going to run at 5 volts. Okay, so you need to lift that pin. You can see how I've done it. Lift the pin and power this NPN chip at 12 volts. And you've got 12 volts on this board because it's coming in on the DC input here or over here, whichever one you're using, right? They're both connected. And you can see by connecting that power, that pin, lift it out, connect it to DC, you're now running the NPN array chip at 12 volts. It will be able to switch your relays back and forward, no problem. So I've got the amp powered on now, it's in standby. I just want to quickly demonstrate, I guess, from the inside of the chassis, how this switching is working, right? So I've got my 3 momentary push button switches on here. And on the video, hopefully you can see the inside of the chassis where I've got these LEDs mounted, right? Little word on the LEDs. So when you're running 12 volt relays, I've got a 12 volt VCC DC line on here. The 12 volt DC is the supply line for these LEDs. Use a 1K resistor. It's shown in particularly the MC2 layout, the most recent one. I'll show you how to wire those up. It's 1K dropping resistor for your LEDs. If you run your LEDs with a 470 ohm, it's too bright. They're just like torch lights, way too bright. If you try to run the LED with no dropping resistor at all, you'll blow it. And it'll emit a little bit of smoke and it'll be game over. Right, 1K resistor is for 12 volt on these red LEDs. Seems to be a nice kind of balance. So let's have a look. Push button, right? There's the that's the gain boost, rhythm boost. Oop, there we go, this one, and channel. Right, simple as that.